So we're looking at prompts 855 and 856, which is applying the idea of reciprocals in a different way. In the previous problems, we looked at the graph, and we kind of sketched them to look at how they relate to each other, and we looked at the table as well. And now this problem is really saying, hey, use that graph and table to find the value of x on the interval from 0 to 2 pi, for it looks like we have sines and we have cosecants. So we're going to go ahead and look at those. But I want to rely on, you can see over to the right, I want to rely on a unit circle to help with this. Now we're not going to take a reciprocal unit circle, but we're going to use it to kind of realize we've been dealing with cosecant. If we dealt with sine, we've really been dealing with cosecant. Or we dealt with cosecant, we're really dealing with sine. That's the idea of the reciprocal. But always be familiar with the order directions. Now, it is saying solve, and we're being asked to solve over the domain 0 less than or equal to x less than 2 pi. Now, that means one rotation around the unit circle. We are trying to find the angle between 0 to 2 pi, or angles between 0 to 2 pi that fit the characteristics. So in this case, I could go to my graph or my table and, okay, what angle gives me a sine of x equal to -1/2? But I think we should practice the unit circle for it. Sines represent y values. So if I want a y value of -1/2, it's about right there. That would be this and this. So this angle and this angle would give me a y value of -1/2. So what are those angles? They're small slices. They're the third and fourth quadrant. Small slices meaning sixths. So it's a little bit beyond 1 pi. So in this case, I know x equals, it'd be a little bit more than 1 whole, so that'd be 7 by 6, and a little bit less than 2 pi, so that'd be 11 by 6. So I mean, that one we could just use our unit circle. But then if I go and say, okay, well, here's the unit circle, here's what we've been dealing with, and I want to find my cosecant of x equal to 2. Well, we can't in any way do the reciprocal of the unit circle, but can I do the reciprocal of cosecant? I mean, if cosecant of x is really 2 over 1, then wouldn't that make the sine of x equal to 1/2? And so that's going to allow me to use the unit circle. If I change cosecant into sine, where does the sine of x equal 1/2 on the unit circle? That would be about right here, which is here and here. So boom, boom. So that is, looks like we're in the first quadrant, a little small slice again, so that'd be pi sixths. And in the second quadrant, we're a little bit less than 1 whole, so that'd be 5 pi sixths. So that's really what I'm going to be looking at, is I can, by the way, go to the graph, see cosecant of 2, they're right here, so it'd still be pi 6 and 5 pi 6. I can go to the table as well, a cosecant of 2, pi 6 and 5 by 6, but I want us to kind of relate the idea of reciprocal, meaning to take it and put 1 over it or to flip it, and we'll get it. Now, sine of x equal to 1, that means you have a y value that equals 1. So in that case, that put me up here, and so that would be pi halves. So x equals pi halves. So that's just unit circle. But let's go to D, cosecant of 1. Well, wait a minute. Can't find cosecant on the unit circle, but I can do the reciprocal. So 1's really 1 over 1. So the reciprocal of cosecant is sine. The reciprocal of 1 is 1. So in that case, it's still pi halves. So sine of x, radical 2 over 2. I'm just going to go ahead and tell you that is pi fourths. And that is going to be 3 pi fourths. But what if I want cosecant of x equal to radical 2? We can use the table. We can use the graph. But what I'm going to do is I'm going to take the reciprocal. I'm going to do 1 over radical 2. That's going to be equal to the sine of x. But there's a problem. Can't have a radical on the bottom. So then what I'm going to do is I'm going to multiply both sides by radical 2 over radical 2. And so that gives me square root of 2 over 2 equals sine of x. And you may be wondering why I'm writing it on this side. It's because that's the same exact problem as what we have over there. It's going to be the same answers. But the main idea of why we're doing this is for you to realize you can't use the unit circle directly to get cosecant of x. But you can use it when you take the reciprocal of that ratio, because it creates sine of x. And then do what we've been doing since chapter 2. Now the next part is, how do you use your calculator then? Well, you may not realize what we've been doing is how you're going to use your calculator. You do not have a cosecant of x button in your calculator. And I would make sure you write this part down. You may go, well, it's the inverse of sine. But it's not the inverse of sine. It's the reciprocal of sine. Inverse of sine is used to find angles based off of a given sine ratio. These two do not mean the same thing. That is a really important thing for you to realize. So then we have this. We have the idea that sine of x is the reciprocal. So 5 is really 5 over 1, and I can flip it. Well, that's not on the unit circle, right? So there's a reason why I'm not going to the unit circle. So I can go to my calculator and type inverse sine of 1/5. And when I type that in, you're going to get, I'm going to pull out my calculator, and I have about 0.201. So that is how we're going to work with these problems.